Okay, so determine the area of the region between two curves by integrating with respect to the independent variable and find the area of a compound region. So that's when it may cross over. So what we're talking about here is simply this. If we have a curve that's above and a curve that's below, we can integrate f of x minus, g of x dx from a to b. And that'll give us the area between them. We'll subtract one from the other. And so you can integrate the one, integrate the other, find the values and subtract, or you can do the algebra in the middle and then integrate the result. And we tend to find the algebra in the middle. So that's what this is saying here. So the same thing. So where f of x is the bigger one. So we start off with something pretty straightforward with R is a region bound above and by the graph of the function f of x equals x plus 4, and below by the graph of the function g of x equals 3 minus x over 2. So we're going to graph this from 1 to 4. The x plus 4, I'm just going to roughly draw something that's going up like that. The 3 minus x over 2 means you have a y-intercept of 3, and it's got a negative slope. So it's going down like this, negative 1/2. And so we want to know from 1 to 4, what's that area between them? So we're looking at here to here. We want to know what that area is. And it's really no more difficult than saying the integral from 1 to 4 of the x plus 4 is the upper curve, minus that 3 minus x over 2 is the lower curve. It's integrating that. The upper curve minus the lower curve. And if we're doing this algebra work, we would have x plus 4 minus 3 plus the x over 2 dx. So what is x plus x over 2? Very good, thank you. So we have 3x over 2 plus 1, good. So we integrate. What is 3x over 2? What's the antiderivative going to be? Anyone at all? 3x squared over 4, good. Plus antiderivative of 1 is x from 1 to 4. And just apply the limits of integration. Okay, so it's 12 plus 4 is 16 minus that's 3/4 plus 1 is 7/4. So what is that? 48/4 minus 7/4. Is that 41/4? That seem right? No, because I didn't do my math right. It's 64/4. So that's 57/4. That's the area between the curves. Okay, let's try another one. It's a turkey.
Turkey, ham, and salami.
Wow, it's a fancy sandwich.
My typical sandwich. I can't just have one meat. That's too plain for me.
How about the mustard? Do you use the mustard? Do you use fancy mustard?
No,
Okay.
just yellow mustard. I don't like the Dijon.
I don't like it either. Okay, here's the big question. Mayonnaise,
Just a little
Miracle Whip, or mayonnaise?
mayonnaise.
Okay. I like Miracle Whip, but no one else in my family does, so we get mayonnaise. Here's the next one. F of x equals x over 2 plus 5. G of x equals x plus 1/2. So which one do you think is the upper one? Why would F?
The F of X has a higher wire, so.
So that one is starting here, goes up at half slope. And the other one starts down at 1/2 down here, but it goes up at a 1 slope. Well, they will cross, obviously, but where will they cross? I'm just going to double check that. Where is x over 2 plus 5 going to be equal to x plus 1/2? I can subtract the x over 2, subtract the 1/2. So I get, it's at 9/2 equals x over 2. So x equals 9. Okay, it'll be well beyond. So that's at 9. We're talking about stuff happening from 1 to 5. Right? Okay, so let's set up the integral. How do you think we should set this up? Integral of what? What should the limits be? Bless you. What's that? 1 to 5. Good. So let's do our algebra here. X over 2 minus x would be negative x over 2. And 5 minus 1/2, that would be 9/2. And if we integrate that, what are we going to have? What's the antiderivative of negative x over 2?
Negative X squared over 4.
Very good, over 4, because it's already a 2, we divide by the 2, so it makes it a 4, plus the 9/2 x, right? From 1 to 5. So we have negative 5 squared over 4 plus 9 over 2 times 5 minus negative 1 squared over 4 plus 9 over 2 times 1. Question? Okay, I have negative 25 over 4 plus 45 over 2 minus the negative makes that plus 1/4 and then minus 9/2. I'll admit I put this in the calculator at this point and I got 12. Okay, let's go ahead and try another one.
On the -5 squared.
Yeah,
When it be 25, because there's no parentheses, okay, it should be negative.
the negative applies. Negative applies after you square it.
Okay.
'Cause it-
didn't see parentheses.
The negative is here. So it's a negative of x over 2. So it's like you could factor the negative out and then integrate, and it applies later on. So if you want to see it like that,
Yeah.
and same thing there. Okay, let's try one that's different. They don't give us the limits of integration for this next one. Far as the region bounded above by the graph of the function f of x equals 9 minus x squared over 2, and below by the graph of the function 6 minus x, find the area of the region. So what we have is, for lack of a better just drawing, I'm going to draw this. It's a parabola that opens down. And whenever x is 0, it's up here at 9. And the other one is 6 minus x. So it has an intercept of 6, a slope of -1. So it's doing something like this. So we want to find the area of that region, but we have to find these limits of integration. We have to find those intersection points to know the limits of integration. So we can take 9 minus quantity x over 2 squared and set it equal to 6 minus x. And we would end up with, I don't think we're going to win on this one. It's going to be a little bit of work. So if we subtract the 6, and add the x, we're going to end up with a 3 plus x minus x squared over 4 equals 0. And for my sanity, I'm going to multiply everything by -4. And that's going to give me x squared minus 4x minus 12 equals 0. A little factor, won't it? That's x minus 6 times x plus 2 equals 0. So x equals 6 and -2. So those are our limits of integration. Okay. And we can set it up now. As the integral from -2 to +6 of 9 minus x over 2 squared minus 6 minus x dx. Okay, it's just a matter of evaluating the limit or evaluating the integral. Let's see, -2 to 6 of 9 minus x squared over 4 minus 6 plus x. So it's really what we had over there for that expression. Integral from -2 to 6 of 3 plus x minus x squared over 4 dx. So we have 3x plus x squared over 2 minus x cubed over 12. Correct me if I'm wrong on that. Okay. So we have 3 times 6. I'm going to go to the calculator here. Plus 6 squared over 2 minus 6 cubed over 12 minus the quantity 3 times negative 2 plus negative 2 squared, quantity squared over 2 minus negative 2 cubed over 12. And what's that going to be? Three times 6, we know that, plus 36 over 2 minus 6 cubed is 216, isn't it? But I got a calculator, so let's do that. Minus negative 6 plus 2 and I get 21.33333 units squared. Okay, that wasn't so bad. Any questions there? We had to find where they intersected. Boom. Upper curve minus lower curve. They integrate and plug in one's integration. There's one here for you to do if you'd like to try one. The limits of integration, again, not as bad as this one was to find, or maybe you think they're worse. I don't know. Okay. So in this case here, you have an x to the fourth as your upper curve and x as your lower curve. No, the lower curve is x to the fourth. So we have is a case like this. And then it's doing this. But they're talking about this region here. You can almost guess what that value is there. We know where it is over here. So where is x to the fourth equal to x? So to do that, you'd move the x over. So x to the fourth minus x equals 0, and you could factor an x out. You have x cubed minus 1 equals 0. So any ideas where the two places it crosses are?
1 and -1.
Not minus 1. So x equals 0.
Oh, yeah, not -1.
The then x cubed minus 1 equals 0. Now, if you're thinking, because you did the Mobius theorem back when you were in pre-calculus or trigonometry, if you're thinking that that was the, there's 3 roots, there are 3 roots to this. But for the sake of this class, we're dealing with real numbers. So x cubed minus 1 equals 0. So x cubed equals 1 and x equals 1. So that's the other place they cross. So I would look at your integral being from 0 to 1 of x minus x to the 4th dx. So what is your antiderivative of x? Go ahead and do it. I'm gonna step back and let you do it and not take the fun away. Tell me when you have an answer. I'll give you a clue. It's either going to be a decimal or a fraction. Anyone have anything yet? Anyone have anything? What do you have? 3 over 10? Anyone else? Anything else? Okay, so we have x squared over 2 minus x to the 5th over 5 from 0 to 1. That's going to be 1/2 minus 1/5 minus 0 halves minus 0 fifths. So that's a 0. So that's going to be 5/10 minus 2/10 is 3/10. Good job. Okay, way to go. Any questions about that? No? Okay. So that is just the regular ones. You have a curve above and below. Now we have some cases, I'm not going to worry about that one there. Some cases that you would look for, well, it's the absolute value of f of x minus g of x where they might cross. And so at some point, one might be above, then another one might be above. And so in that case, you look for that cross point and break up your integration. So you where the one's on top versus the other one being on top for the other part of it. And so that's what we're going to do next here. So let's say we have f of x equals sine x and g of x equals cosine of x on the interval from 0 to pi. So our sine curve, which I'm sure you draw in your sleep, from 0 to pi looks like that. Our cosine curve looks like this. Oh, no, it's not like that. That was 0. No, that is right. That wasn't 0 to pi. Okay. So it crosses here in the middle at pi over 2. Here's pi. Starts at 1. Okay. So we see for a brief moment the cosine's on top, and then we have a time where the sine's on top. So we want to find the place with the cosine's on top. So this might be a good time to refer back to the chart we did in the last section. So where is cosine of x equals to sine of x? There is a value. It's in the chart. It's one of the ones. Pi over 4, good. X equals pi over 4. So what we're going to do is we're going to integrate this from 0 to pi over 4, where we have the cosine on top. So it's cosine of x minus the sine of x dx. Then we're going to add to that the integral from pi over 4 to pi. For the rest of it, sine is above the cosine. So sine of x minus cosine of x dx. That's it. That's it. The hardest part is setting this up. Now we can integrate this. We all know these antiderivatives. You often correct me on them. So what is the antiderivative of cosine? My gosh, I turned all the volume off. It keeps buzzing. Yeah. Now my wife will be trying to get a hold of me and she can't. Okay. What is the antiderivative of cosine? Anyone know? Sine, good. So we have sine x minus, and the antiderivative of sine is, what's that? Negative cosine. I got to double think on that one. So that one gets evaluated from 0 to pi over 4. And then we're going to add to that. We just said antiderivative of sine was negative cosine of x. The antiderivative of cosine is sine of x from pi over 4 to pi. So we end up with, this is sine of pi over 4 plus cosine of pi over 4, because a double negative, minus sine of 0 plus cosine of 0. Then we have plus negative cosine of pi minus sine of pi minus negative cosine of pi over 4 minus sine of pi over 4. Okay, real important to be careful of these negatives. You got a lot of negatives to throw around here. This is one of those cases, though, that sine of 0 is still 0, but cosine of 0 is not. This is equal to 1. So we have a square root of 2 over 2 plus a square root of 2 over 2 minus 1. And here's where it gets really interesting. Then that cosine of pi, it's a negative cosine of pi. Anyone know what cosine of pi is? It's in the chart we just built. No. Sine of pi is 0.
Oh, negative 1.
It's negative 1. So it's negative of negative 1. And then we have minus a negative cosine of pi over 4. So I'm going to make that, well, a negative square root of 2 over 2. And then a minus a negative square root of 2 over 2. So we have square root of 2 over 2 plus square root of 2 over 2. We have minus 1. Oh, look at that. Plus 1. Then double negative makes it plus the square root of 2 over 2, double negative, plus the square root of 2 over 2. So in the end, we have, that's interesting, 2 square roots of 2. Because the 1 and the negative 1 subtract out. Okay, again, we found where they crossed, and that became the breaking point for our integration. 0 to the first, to that point to the other end of the interval. Placing the one that's above where it needs to be, and then we integrate and apply limits of integration. That's pretty much it. Let's do another one. We're ready here. We got way to the right there. Okay, just did that one. This is kind of the same thing. I don't really want to do this just for time's sake. What were these crossed though? Your sine's doing this, right? Your cosine is doing this. Bottoms out there. There it goes. Comes up there, like that. There we go. Probably being a perfectionist on my cosine curve. So this one is talking about going from pi over 2, which is right here, to 2 pi, which is over here. So you see there's a place where they cross, such that sine's on top and then cosine's on top. And that place, we didn't go through that in the chart. I didn't go out that far with everything, but that's going to be where sine of x equals cosine of x. There's another place where they're the same. And that's at x equals 5 pi over 4. So your integral is going to be from 0 to 5 pi over 4 of sine of x minus cosine of x. And then plus integral from 5 pi over 4 to 2 pi of cosine of x minus sine of x. Okay. That's the setup for it. And again, we're looking for the place where they cross, and that's the other place they cross. So what I would suggest, if you weren't able to do that, or if you get a problem like that in the homework, go to Desmos and graph the two and see where they're crossing, and it'll tell you where they cross. And then that'll be your change there. Yeah, that's your setup. I want to go ahead and show you a couple more things, really one more thing that's pertinent here. Very much related to this, but it's a little bit different view of it. So, oh, looks like Christmas colors. Down here, consider the figure. So in a case like this, so we want to know the area under this curve. And so it's important to know where they're crossing, and their crossing looks like at 1. And we can double check that. We can say x squared equals 2 minus x, see where they're crossing. Obviously this, if we expanded this is going to go up, and they're going to cross back there, probably at -2. But bringing everything over, x squared plus x minus 2 equals 0. So x plus 2 times x minus 1 equals 0. X plus 2 is 0, x equals -2, and x minus 1 equals 0 means x equals 1. So these are going to cross, this changeover happens at 1. So in a problem like this, we would have, I'm going to go back to blue because I like blue. That's why I like green for one area, one thing in my life, and I like blue for writing. So we have integral from 0 to 1 of the orange curve is above, so that's x squared dx. And then we have the integral from 1 to 2 of the 2 minus x dx. So in this case, your lower curve is just the x-axis. So you don't need to write y equals 0, subtracting the 0 that's applied. So it's trivial. So this is how you break that up. When you see that in the homework, you're looking at not so much which curve is on top, but which curve represents the upper one. This is not one on top, one on bottom. So if we did this, that's x cubed over 3 from 0 to 1 plus 2x minus x squared over 2 from 1 to 2. We have 1 cubed over 3 minus 0 over 3 plus 2 times 2 minus 2 squared over 2 minus 2 times 1 minus 1 squared over 2. So looks like this is a 1/3 plus 4 minus 2 minus the 2 again plus 1/2. So really we're at 1/3 plus 1/2. Who likes to add fractions? I get 5/6. Okay, we have one more problem in this section, if you'd like to see that. It's a similar problem to this, where we're trying to find the place where it changes. Here it is. So the region depicted in the figure, find the area. So what do you think that change point? It looks like it's indicated to us, but I would probably verify it. I'd probably clean this up and multiply both sides by 2. So it'd be 2 times the square root of x equals 3 minus x. And now I'd square both sides. I know that first step really didn't need to happen. That's 4x equals 9 minus 6x plus x squared. End up with 9 minus 10x plus x squared. This is interesting. So that factors to be x minus 9 times x minus 1. So thing is that x minus 9, unless I did something wrong, it's never going to cross there. It's irrelevant because it's not within the bounds we're talking about. So x equals 1 is where it is. So with that, I'm not going to write it. I want you to write it. Someone tell me what to write. What would your integrals look like in integrating this one? How would you integrate that? There's going to be 2 integrals, but we know it changes at 1. So I need someone to tell me what is going to be inside each of these. What is that upper curve? That's square root of x in the first part. And then you said 3/2 minus x over 2. That's your second one. Good. So now you have it set up. Now you integrate. How did you integrate your x, square root of x? What'd you do for that? Anyone? What do you do? You have an x at the 1/2 power. What do you do to that power?
X to the power of 3 over 2, all over 2.
So you did x to the, add 1 to the power, so 3/2, we divide by 3/2, and that's where you got, it's gonna be, it'll be 2/3.
Oh, yes.
And plus the 3/2 becomes 3/2 x minus x squared over 4 from 1 to 3. So 2/3 times what? We have 1 to the 3/2 minus 0 to the 3/2 plus 3/2 times 3 minus 3 squared over 4 minus 3/2 times 1 minus 1 squared over 4. We have 2/3 times 1 plus 9/2. Oh, wait, minus 9/4. Then we have a minus 3/2. Then we have a plus of 1/4. Is this going to work out? I guess it will. Yeah, it will because of 3/2. Okay. So it's 2/3 plus 9/2 minus 3/2 is 6/2. Negative 9/4 plus 1/4 is negative 8/4. So it's 2/3 plus 3 minus 2. So it's 2/3 plus 1, which is 5/3. 5/3. Okay.